to everyone that's here for computational biology, and I'm giving an education talk. I learned so much last year attending SciPy about education, I submitted a manuscript, and then there wasn't a track on it this year. So I hope you find it interesting anyway. So what we're talking about here is we're reporting on our experience since 2005 of teaching Python as a first programming language for biomedical scientists. And this was at the University of Pittsburgh and most recently at the University of Utah. And so just by definitions, by scientists, I really kind of mean graduate students. And there's always exceptions. There were some postdocs, junior faculty, undergraduates that have taken the courses over the years. And when I say biomedical scientists, most of the students came from biomedical informatics. More recently, that's been expanded in teaching in a program that includes biochemistry, biology, human genetics, et cetera. Had a fair number of math students a couple of years ago. To understand what our product we're trying to create through these courses, it's good to know what the field is. And so biomedical informatics, from their own professional organization definition, is an interdisciplinary study that pursues effective use of biomedical data, information, and knowledge, et cetera, in healthcare. And so biomedical informatics includes very biologically oriented aspects and clinically oriented aspects. Most of the students, especially early on, were very interested in clinical kind of questions, focusing on working with clinically generated and consumed data. That still leaves kind of the definition of what informatics is. It's kind of one of those terrible names because no one knows what it means. But my favorite definition comes from the University of Edinburgh that says informatics is the science of information, studies the representation, processing, and communication of information in natural and artificial systems, et cetera. And so it has computational, cognitive, and social aspects. So those are all things we're trying to ingrain in the students. We said biomedical scientists. I really like Fred Brooks, who said the scientist builds in order to study, the engineer studies in order to build. Speaking of poor names, he really hated the name computer science. So really kind of, if you get down to it, most people that have taken these courses were really kind of engineering oriented. They were trying to build tools to better deliver healthcare. So what was the problem? So at the University of Pittsburgh in early 2000s, they realized that they were enrolling graduate students into their program that did not have sufficient programming skills to be successful in their program. And so they discussed, do you do an in-house solution or do you outsource this to somebody else to do the teaching for us? And they concluded the outsourcing wasn't working, and so a faculty member prior to me created a course that he entitled Problem-Oriented Programming with Python. I really liked that title. I don't know that I kept that philosophy as when I took the class over a few years later. So what were our raw materials? So as students in an informatics program, people were coming from all over the place. We had librarians, physicians, linguists, dentists, biologists, engineers, nurses, psychologists. And just as you have a range of backgrounds of the students, that there's a range of ages. So I think my oldest student was in their 50s. Had students as young as 20, 22 that were in the class. So we're taking all these people from all these backgrounds, taking them into one program, and trying to produce this output of a biomedical informaticist. And so that was very challenging, which is one of the reasons that just kind of outsourcing the classes didn't work very well. It really took a lot of tailoring and hand-holding to the students to get them through this process. So what did we want to produce through the class? So we wanted students who understand biomedical data and problems and how computation can be used for these problems. And we hope that at the end of the course, we would have created students who can continue to learn and improve their Python programming skills on their own. This is time limited. We have a semester. Don't have a lot of time to get them everything, so that hopefully we'll get them on the path to learning on their own. Successfully use Python and other programming-oriented courses. Use their experience with Python to teach themselves another language if that's more pertinent to them, and use Python in their thesis or dissertation work. And basically what we looked at is what kind of product is what were the faculty working on. The faculty weren't computer scientists. They were applied informatics in the health domain. And so we looked at the kind of things that the faculty were using computationally and tried to use that to frame the curriculum. So we described the course as a boot camp. This is one, we wished you knew all this beforehand. We're going to give you a semester to kind of catch up. Consequently, you should expect that this will take more time than maybe an average class that you've enrolled in. We also assumed that the students were self-motivated. A lot of them had left careers to come back to school, so they were stepping away from salaries, et cetera, so we assumed that they were self-motivated and that they were interested in learning more than in receiving a grade, although you do have to grade them. Although I started graduate school in the University of Wisconsin in plasma physics, and Stuart Prager told me, you should never worry about your grade. The only thing people are going to care about is your dissertation. I don't know if that's true. I tell my students that all the time, and I don't know if they listen or if it's bad advice. I should follow up on that. Very traditional course, but we added some things to kind of make it more interesting. We've added peer code review. One of the favorite things over the years the students have liked is class-wide programming assignments where I use a random student selector to call up the next person that's going to write the next function in the program. That makes sure that they're paying attention. When everyone has their own computers, it's easy for people to zone out of the class. Despite the stress, they seem to like it. Course projects where they implement, try to get them to take their own domain and solve a problem that's different than what we're doing in course. And that's basically done over about half the semester. So does the class work? Well, as instructors, we think the course has been very successful. The vast majority of students completing the course achieve a functional proficiency in Python by the end of the semester. Term projects frequently expand into thesis or dissertation projects. One student that came in with a political science degree had never programmed before. He started hiring himself out to other students and staff and faculty that wanted little programs written for him, which slowed his own progress down. And he was a major in the Army that had his full-time salary, so he didn't really need the money. He just liked it. A couple of the students that over the years have made comments that have really been stuck with me. One called it liberating, after having about 3 or 4 years in graduate school where she was always relying on her advisors, programmers for things. Another person was just visiting in the class. He was a practicing pathologist. Said it was life-changing. He realized what crappy software he had been given. And he ended up dropping out of his practice and enrolling in graduate school at Stanford, and now he's employed by one of the 50 smartest companies in the world, according to MIT. There have been a lot of challenges along the way. Maybe the biggest one is lack of computer skills among students. Tools like Anaconda, Canopy, IPython notebooks all help that because they don't have to interact as closely with their computer, which they don't know how to use even though they thought they did before the class. There's kind of a general lack of problem-solving skills among students. This varies by student, by discipline. Math students have done very well in this. They have difficulty learning how to debug their programs. That's kind of an obvious programming idea. But they also kind of have a difficulty tackling open-ended questions, starting with a simple solution, getting that working, moving to a more complex. They just can't kind of think in that way necessarily. It's very challenging to keep the class relevant to each student. That's due to the breadth and also due to the diversity of where the students want to end up. As I listed at the beginning, we talked at the beginning, we mostly started with kind of these clinically oriented people, and now we folded in all these kind of biologically oriented people. They have a different skill set that they want at the end, and so that makes it hard for one class. One of the most interesting challenges is access to data. This is not so much a problem with bioinformatics where NIH kind of sharing rules. There's a lot of data out there. Also with images, medical images, there's a lot of data out there. But for real kind of clinical data, it's really hard to get your hands on and use it for teaching. So one year I have a very rich medical history. I took my own medical records, posted them on our course website. This is the University of Pittsburgh. The University of Pittsburgh Medical Center scans all the University of Pittsburgh computers looking for PHI data. They spotted this, informed our department that if they didn't remove the data, they would shut the department's computers down. And I tried to tell them, it's my data. They could have cared less. It was, get it off the computers or your department won't have any computers. So that was an interesting experience. We thought it was successful. Did the students think it was successful? So we reviewed course evaluations, and we also created a SurveyMonkey survey, we were using the free version, so we had to stick with 10 questions. We're not professional survey designers, so we certainly could have done a better job. But we emailed it out to all the students over the previous 10 years that we had records for. We had about 27 responses. One was completely blank. That represents about a third of all the people that I've taught. They've tended to be smaller classes. So I call it a first programming class. We asked them what their experience levels were, moderate. Some we meant that you've tried to teach yourself programming or you've taken a programming class before. The department required a programming class as a prerequisite. Honestly, as an instructor, I couldn't tell the difference between someone that had one programming class and someone that had no programming class for the most part. But you see, most of them did not consider themselves to have much in the way of programming experience prior to the class. What were they doing? What do they describe kind of their domain? There's a lot more recently kind of this bioinformatics, but kind of a spread of things that we kind of categorize: natural language processing, text processing, task automation, etc. What did they most appreciate learning? They seem to like most of what I kind of categorize as the topics. Someone put databases in. Web programming is kind of one of our illustrations of using databases, so that was intended to try to enforce that. But they liked almost all the topics. Probably the hardest one for most people is regular expressions. That's where all the blank expressions were on their faces when we're teaching that. Then we asked them kind of on a Likert scale, do you value the class? And so the question was, learning Python was valuable for my career development. 24 out of 26 of the respondents strongly or agreed or strongly agreed, and it was about half and half on that. Only one disagreed. Programming is an integral part of my professional work, about 2/3 it looks like. Some people were just supervisors of programmers now. Python is my primary programming tool. About half of the students now still holding on to Python as their primary programming. And learning Python is valuable for helping me subsequently learn additional programming language. 21 out of 26 said it was valuable for that. Like I said, some people responded that they just don't do programming anymore, or probably never have beyond the class. We asked them, where are we failing and what are we assuming wrong? So we asked them what they wish they knew prior to learning how to program. I think this has been similar to what other people have reported. Almost all of them wanted to know something more about command line, shells, terminals. Some specifically answered Unix and Linux, and I think that's really kind of this bioinformatics crowd that are learning. They're coming and they've been these Windows users as children, kids, and they just see how many powerful tools there are in Linux and Unix, and they see how much they're missing. They want to use that. One person actually said they wish they knew how to program before they took the programming class. And problem solving, like I said. So, we're asking them, we've identified these as problems. Do you see them as problems? And I think that they're seeing the same things. People that, we asked them what they perceived limitations of Python were. People mentioned memory management, speed. One said they didn't consider it a statistical language. And maybe the most frequent one was the people they're working with are using another language. And so that's a limitation of trying to use Python. What did they like? They liked learning what they can do. That with a little bit of skill, there's all these packages out there that, they're just amazed at the kind of things they can create. They liked learning about these pre-existing packages. I asked about scikit bio. A couple of students said, they just wish that I told them about BioPython in the second day of class, and then they would have learned it, and then the rest was just kind of icing. They really like the in-class group programming. They like kind of the group thinking, the group working through a problem, kind of that modeling, problem-solving idea. And they like the course projects, and they wish that we could incorporate that earlier into the class, maybe have the homework's framed a little more flexibly around creating course projects, et cetera. Some of my favorite survey responses: the Python course is one of the best courses I've ever taken. Of course, I like that. They liked that they became comfortable with their own work and incorporating, understanding what other people are doing. Learning how to read code and think logically is the best part, which continues to help me today. The confidence, it was initially difficult to learn, but once you start thinking that way, the learning accelerates. And you do kind of see that. People struggle, and then it kind of clicks. and then they cruise through the class. And the trick is keeping them there long enough that they get to that click point. Typical complaints, sometimes my lectures were disorganized, a long time to get homeworks graded. There was some person that was really adamant about it was a problem that I was using a Mac. No one mentioned it, but I had frequently confused them because my text editor is Vim, and they couldn't figure out what I was doing. Favorite complaints, the first year I taught it, a student came up to me in my office and said, "You should apologize to this class for making it so hard." I do think it's important to pay attention to what the students are telling you, et cetera. I did talk with some colleagues and peers, and I did not apologize. I do try to adjust. Sometimes I'm wrong, and I make a homework that's really terrible, and it really was terrible, et cetera. But class was too time-consuming. These are quotes from the surveys. I was behind on day one and was drowning in information. I felt like the class was preparing to take the midterm on the second day of class. Way too much work. I cannot stress this enough. Spending 12 hours on homework a week is not. And I'm just curious about those that have learned to program, this complaint about 12 hours a week, just kind of you chuckle. Okay, so we're redesigning for the future. We really do need to think of the programming class in terms of a sequence of things, and so we're going to, work on, and as much as possible, incorporating online resources, but teach them Linux shells, problem solving. I'm going to really kind of tackle that. I think that's an interesting problem of how to teach problem solving. We're probably going to have like a really short, maybe 1-credit programming course beforehand, and then we kind of repeat and run off on it later. Since last year, like I said, I was really struck by the program last year. I've hooked up with some educational experts that are helping me think about how we can redesign and evaluate going to the future. A lot of online, compared to 2005 when I started teaching this, it's a lot different environment of what resources are available to you that you can draw into your class. Things I'm thinking about, break the class into smaller parts. In academics, we tend to think of these chunks because it makes it easy to administer. But maybe what we need are a lot more small chunks that people can plug and play to get the kind of training they need. Can we let them self-select the pieces? And I think the big thing, the students mentioned this a lot, they took this programming class, and then all their subsequent informatics classes didn't have programming. And so they could just kind of see their skills kind of just fading away as they weren't forced to kind of practice it. And so my wife is the new department chair at the University of Utah, and so she's letting me work with others to make sure that programming is integrated into subsequent classes. So with that, thank you and goodbye. Alan. It's varied over the years. The last couple of years, I've, had links to the different Safari books that are on the library subscribes to. Since all your books are kind of Creative Commons, I kind of think that what I want to do is kind of take your materials and just supplement it with the kind of medical, bio-specific things. But I've struggled. Since your book has been on Green Tea Press, I pushed that to people as a resource. I've probably used 3 or 4 different kind of textbooks or required books, and I've never really been greatly happy with them. And I've kind of slipped away from that. I think that's a mistake to the students. I think it's good to have a structured second resource besides the instructor to help them. Anything else? Oh.
I teach bioinformatics, and we're kind of thinking of doing something similar, like building a boot camp as maybe a 1-credit lab that would go along with the class. This is bioinformatics,
Right.
mostly for biology students. And one thing I was thinking was maybe taking the software carpentry material and splitting that over a semester. Have you thought about doing that?
Well, I've started looking into most of my lectures. I have links to software carpentry as additional materials. I think that the really thing that we have to do is make sure that we're incorporating the relevancy. If we take these other resources, that we're flavoring it and adding in the biology, the medicine, et cetera, because they they don't want to learn how to program per se. They want to learn how to solve their problems. And so once you start, we've done card decks and different hangman games at the times, and that's kind of a nice diversion occasionally. But they're graduate students; they want to be thinking about their problems, and it kind of raises the question of when to teach the class. If they have a project idea in mind, they do much better in the class than if they're just kind of floating around. And so in Pittsburgh, we taught it their very first semester. This year, it's like the second semester of the first year. We're thinking of making a summer. We've put in an R25 for a BD2K program. So we're thinking just move it to part of that. It's a summer program. Maybe they finish their first year. They have domain knowledge. They have some ideas. And then this summer, we work on getting them some skill sets. All right, thanks. Oh, sorry. I think I get good reviews for that I care. I'm evil. I make the class too hard, but I care. I want them to succeed. The classes, when I started at Utah, the first class was 35, and the next one was in the teens. At Pittsburgh, they're all kind of around 10 or 12. So it was small enough that I could give a lot of hand-holding. The informatics classes tend to be kind of fairly split between men and women. The big issue that I saw in terms of confidence is they group up, and you get positive reinforcement of negative ideas amongst themselves. And so this year I tried a little more. You get a couple of whiners together, and it really amplifies the whining amongst them. But it hasn't been something that I've noticed per se. All right, thanks.